The $12 billion James Webb Wide-Range Infrared Telescope, said to be 100 times more capable than Hubble, promises to tackle cutting-edge issues in cosmology and exoplanet research. Today, I will tell you why the James Webb Telescope is so important for science. You will learn the secrets of this device and what advantages does it have over its predecessors. What is James Webb Telescope? The James Webb Space Telescope has several advantages that no other existing or soon-to-be ground-based or space-based telescopes can match. James Webb itself has become a real long-term construction project and has been under the threat of closure more than once. The project started in 1996 and cost $12 billion by the time it was launched. Such terms and costs are determined by the highest complexity of the device and the requirements for design accuracy, quality of observations, and a 10-year period of active work. A distinctive feature of the telescope is its main folding mirror, made up of 18 hexagonal segments. At the telescope, not only a mirror is unfolded, but also a heat shield, and together with optical elements, it becomes a real space transformer. The new telescope is most often compared to the Hubble Space Telescope, which has served the world of science for more than 30 years. The diameter of the main mirror of Hubble is 2.4 meters, while that of James Webb is 6.5 meters. There are larger telescopes on Earth. For example, the Grand Canary has a diameter of 10.4 meters, but because of the atmosphere, it can only be compared with Hubble, and even then, not in everything. Space telescopes have the ability to accumulate light for a long time during observations. In photography, this is called shutter speed. That is shutter open time, during which light is projected onto the photosensitive elements, and the possibilities of digital image processing allow you to summarize several frames of the same place. Together, this allows long-term accumulation of photons. For example, the record-shooting Hubble Extreme made it possible to create a picture with a total exposure of 2 million seconds or 23 days. Such a review made it possible to look into the early times of the universe up to 13.2 billion years ago. That is, the oldest recorded galaxy is about 600 million years old from the Big Bang. The James Webb Telescope is located more conveniently for observations, but inaccessible to service shuttles at the Lagrange point L2 in the Earth's Sun system. This is a region of space from which both the Earth and the Sun are always approximately in the same region of the sky. This means that observations of selected targets will not have to be interrupted every 45 minutes, as is the case with Hubble. James Webb will always be oriented with its back to the Sun, which means that the rest of the sky will be available for observation. The annual movement around the Sun allows you to observe any point in the universe. The diameter of James Webb is about 2.5 times that of Hubble, and this is one of the most important parameters that determine the resolution of the telescope, that is, the ability to distinguish the smallest details in the pictures. However, the resolution of the telescope also depends on the wavelength of the light being observed, and here the infrared telescope loses to the one that observes in the shorter wavelength visible range. The wavelength of light visible to our eyes in the range averages 0.5 microns, and the main JW instruments register from 0.6 to 5 microns, which means that the resolution of James Webb images will start at double superiority over Hubble and go to 5 times lower resolution due to the longer wavelength of light. But the large diameter of the telescope also means a large area of the main mirror that collects light. Here, James Webb is 5 times superior to Hubble, which also improves the quality of observations. The most difficult engineering task is to ensure the thermal regime in space, which depends on the operating conditions of the spacecraft. For example, the thermal insulation of the Hubble telescope is primarily concerned with maintaining a stable temperature of the telescope, regardless of its location on the sunny or shadow side of Earth orbit. However, the temperature of Hubble itself and its light-sensitive detectors is close to room temperature. In contrast, James Webb has an operating temperature of 223 degrees below 0 Celsius. This allows you to observe a much larger number of space objects that emit or reflect light in the infrared range. JW's 5-layer thermal shield immerses the telescope's optical systems in an artificial shadow, causing them to cool to ultra-low temperatures by natural radiation. In addition to that, one of the instruments of the telescope has an active cooling system, which reduces the temperature of the detector by another 44 degrees to -267 Celsius or 6 kelvins. All this is necessary in order to see not only farther and deeper, but also colder and darker. Space is a pretty dusty place. Although it is not visible to our eyes, one of the reasons why our sky does not shine with billions of stars is interstellar dust. Astronomers even have the term zone of avoidance. This is the part of the sky where interstellar dust clouds in the plane of our galaxy are so dense that they do not allow observations of distant objects. It was interstellar dust that for a long time did not allow confirming the presence of a supermassive black hole at the center of our galaxy, and it was with the help of infrared observation that this was confirmed. The reason for this advantage of infrared light is simple. Dust absorbs light at a wavelength that is shorter than the size of a dust particle. Astronomical observations are now being made in almost all ranges of electromagnetic radiation, but there are two main reasons that have made infrared a priority for James Webb. These are interstellar extinction and cosmological redshift. The first effect is caused by dust in interstellar space, and the second is caused by the expansion of the universe after the Big Bang. In addition to optical features, James Webb has a serious set of spectrometric instruments, so some of his discoveries will not always be accompanied by beautiful photographs. Here, organic matter can also be found in the water fountains of Enceladus and Europa, and the composition of the atmospheres of relatively nearby exoplanets has been determined. Perhaps it is thanks to James Webb that an Earth-like planet suitable for a settlement